Okay, so we are going to do some problems that are similar to the test, and we're just going to practice. We're going to do a video, so this is not a worksheet or anything. It's just some questions we're going to practice. So here's the first one. So we're going to do a quick graph of this. Okay, so I'm going to do it on the whiteboard. Okay, here's the question. So what you're going to notice is that you have a 0 at, oh, this is kind of hard to see, isn't it? Let me see if I can get this so it's not so blurry. All right, so you have a 1, 0 at x equals 2. All right, so you take the opposite of that. Then you have a 0 at -3, but it's a double root. -3, double root. So we're going to actually, I don't know how I can do this so you can see at the same time. Double root, dr. And then you have another root at -1, and that's a single root. So you're supposed to have 4 roots. We have 3 because 1's a double root. Now, there is a negative out front. You see the negative? That means that, first of all, let's count our x's. There's 1, 2, 3, 4. Do you see how there's 4 x's? 1. This is 2 of them, and there's 1. So that's 4 x's. So if it's an even and it's negative, they both are going to go down. So your end behaviors are both going to point down. Okay, and then we need a y-intercept. To find the y-intercept, you're going to let x equal 0. Let x equal 0. So in this problem, if you were letting x equal 0, it would look like this. So it'd be the opposite of -2 times 9 times 1. And all of that is 18, because 2 negatives make a positive. So that should be 18. So you got to come up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The y-intercept's way up there. So when you draw this, you're going to start down here at this end behavior. You're going to go up, and this is a double root, so you're going to come down, go back through this one, hit this, and come back down. So it's going to look like this. And there you have it. There's the question. So do your x-intercepts, your y-intercept, your end behaviors, and sketch it out. So this is the only one we really don't know how low it is, but as long as you get that down there a little bit, you'll be good. Make sure this is a double root. Okay, next question. So I need to wipe this up. All right. So the second one, factor completely. We're going to factor this completely. Okay. So I'm going to take a GCF out. Let's take an X out. Looks like I should take 3 X's out. Sorry about that. So you have this. You guys good with the first step? Take a GCF out. Now we're going to factor the trinomial. So we have x and x plus 6 minus 4. So you have a 0 triple root. You have a -6 and you have a 4. These are your x-intercepts. This is factored completely. So when it said factor completely, so notice the directions, say factor completely, that's this. Where it says x-intercepts right here, that's this. Where it says y-intercept, we're going to let x equal 0 in the problem. So if you let x equal 0 in the original problem, it's all 0. So the y-intercept is 0. And that's because in the original problem, they all have an x in them. So if you let x equal 0, they're all 0. So do not get stuck by thinking that's -24. Because there's an x with the 24, that is a 0. So the y-intercept is 0. It also says as x goes to infinity, what does y do? And as x goes to negative infinity, what does y do? So this is a non-calculator problem, okay? So because it's x to the fifth and it's positive, your ends, one should go up and one should come down, like go down this way. So I know you can't see that, but basically you have this x to the fifth. So one end's going to go here and one end's going to go here because of the x to the fifth, positive. So you say as x goes to the right, this end's going to go up and this end's going to go down. Because that's an x to the fifth. Because it's an x to the fifth. Odds, one goes up, one goes down. And it's always the right hand up, left hand down if it's positive. If that would have been a negative, it would have been the left hand up and the right hand down. Okay, that's it for that problem. Factor completely. Okay, number 3. Graph this without a calculator. Also, I would like 2 points per curve. 2 points per curve. So when you're graphing this, the vertical asymptote is x equals -3. Look at the bottom. This is goes back to the first couple weeks of school with the translations. We've already actually taken a test over this. The y-intercept is what's at the end. This is not the ones like that we did last week. This is back from day 1 if this is your 1 over x. Does everyone know what 1 over x looks like? Y equals 1 over x looks like this. It means your vertical and your vertical asymptote is x equals 0 and your horizontal is y equals 0. But if you put a +3 here, that moves this vertical asymptote 3 to the right. So you go like this. Oh, I'm sorry about that. It's 3 to the left. Duh. 3 to the left. And then when you put this -4 here, it just means everything drops 4. That dropping is the actual horizontal asymptote. So your horizontal asymptote is y equals -4. So you have this. And then you just need a couple points. So it's a non-calculator, so if you're doing this by hand, make a t-table. The 2 points that I would plug in if I was you is the numbers that are to the right and left of the vertical asymptote. So I would plug in -2 and I would plug in -4. They're going to be nice numbers. So if you plug in a -2, this gives you 1 over 1, which is -3. So -2, -3 is a point right there. If you plug in -4, -4 plus 3 is -1. So -1 minus 4 is -5. So -4, -5. That's that point that's on. So the only other points that are easy to find are your x and y intercepts. So if you let x equal 0, what is y kind of thing? If you let x equal 0, what is y? So if you go to the original problem, if you let x equal 0, come up to this original problem. If you let x equal 0, that's 1/3 minus 4, which is -3 2/3. So that's a point right there. I put that right there, right above the asymptote. And to find the the x-intercept, sorry, you're going to let y equal 0. So if you let y equal 0, if you let the y equal 0, you have this. Add 4 to this side. Cross multiply. And next is -11/4. So that's what, -3 3/4? So -3 3/4 is about right here. Well, that's not right. I'm having troubles here. Oh, it's not. That's because it's 2 3/4. That makes better sense. And you just draw this in. Here's your curve. This is really hard to do with the whiteboards. I think I'm going to have to do the rest of these on paper because this whiteboard is just too big. So I apologize. I'm throwing out the whiteboard. I'm doing these problems with a pen. All right, so that's the problem we just did. I'm throwing that out. I'm just doing these right on paper. All right, here's the problem. Without a calculator, this problem crosses at -6. Use synthetic division and find all zeros. So I'm going to take the -6, I'm going to plug it in synthetically. So you have 3, 18, -1, and -6. Bring down a 3. 3 times -6 is -18, that's a 0. 0 times -6 is 0. Bring that down and multiply and you get 0. So because it started as a cubic, this is quadratic. So put in your variables. So you have this. Since b is 0, you really just have 3x squared minus 1 equals 0. So you should be able to solve for the other two zeros. Add 1, divide by 1/3, and you get this. Now you are not allowed to have a fraction under a radical, so you should separate the radical first, and then you should rationalize the denominator. So your zeros are -6, 0, radical 3 over 3, 0, and negative radical 3, 3, 0. Those are your answers. So here's another one. Synthetic division, -5. Bring down the 1 times -5, add -2. Multiply, 10. Add, and multiply. So -5 is definitely a 0, and then this is quadratic. So put in your variables, set this equal to 0. Now in this particular problem, there are no factors of 5 that add up to -2, so we're going to do the quadratic formula. So the opposite of b is 2. B squared is 4 times 4 times 1 times c over 2. 4 minus 20 is -16 over 2. So that is 2 plus or minus 4i over 2. Take a 2 out of all of these. And your other answers are 1 plus or minus 2i. So your 3 zeros, which there are 3 because it's cubed, is -5 because they told us -5, and the other 2 are 1 plus or minus 2i. So those are my 3 zeros. This one, what is the slant asymptote? I'm not asking anything except the slant asymptote. This is 1 bigger than this, so that's why there's a slant asymptote. So you set up synthetic division. Coefficients of the top are 1, 3, -3. The 0 on the bottom, the divisor, is -4. Bring down the 1. 1 times -4. Add, multiply, and add. Now, you started with a quadratic. That's quadratic. So what are these numbers? These should be the numbers of a linear. So your slant asymptote should always be in y equals mx plus b form. So in this case, it's y equals 1x minus 1. 1x minus 1, we ignore the remainder. This is your slant asymptote. This one, what does g of x approach as x approaches 4 from the right? So we're gonna, you don't have to do this. You can just look in your calculator. Actually, just punch this in the calculator. Okay, so there it is, x squared minus 16. We're gonna press zoom 6 so we can see the screen. Oops, I just messed up something. Delete. Okay, zoom 6. There should be 2 vertical asymptotes, one at 4, because this is x plus 4 and x minus 4. And one at -4, okay? See them right there? Now this question is saying, what does g of x approach as x approaches 4 from the right? This is from the right. That's what that plus means. If it was a negative, it would be from the left. From the right. So here's the 4. So put your pencil right here at this curve, from the right. As your curve approaches the asymptote 4 from the right, what is it doing? So it goes like that, and it's like a magnetic field. It goes like this, and right when it gets there, it shoots straight up. So you would say g of x approaches positive infinity. So what would it be if I said as x approaches negative 4 from the left? What would g of x approach? So you would look at the negative 4 asymptote, but from the left of it. So from the left, so as you are following the curve from the left, when it gets close to the negative 4 asymptote, what does it curve do? It goes straight down. And this one you would say approaches negative infinity. There's actually 4 end behaviors for this. You could do 4 from the right and 4 from the left. And then you could do negative 4 from the right, negative 4 from the left. That's that. Let's do this problem right here. Solve and write the solution. There's only one of these on the test that has the inequality. So you're going to have to follow your steps. First step, find your discontinuities first. That's your denominators. Like the factors on the top are x plus 6 and x minus 1. On the bottom, it's x plus 3, x minus 3. So nothing cancels, but your discontinuities are x equals 3 and x equals negative 3. You're going to place open circles on these. Those are what it cannot be. It cannot be 3 or negative 3, or the denominator would be 0. The second step is you're going to find your actual zeros of the problem, which are also called your x-intercepts. So we're going to set the numerator equal to 0. So the numerator has these factors. If you set these equal to 0, you get negative 6 and 1. So these should be open circles because of the original inequality. But if I made this greater than or equal, like that, then these would be closed. So let's go ahead and make this equal. Let's make it equal. Go to the original problem, greater than or equal. So these should be closed circles. So at 1, you should have a closed circle. And at negative 6. You should have a closed circle. And we're going to test one number. We're going to test 0. So I'm going to put 0 in the original problem. 0, 0, negative 6, 0, negative 9. Is 6/9 greater than or equal to 0? The answer to that is yes. So you're going to shade all of this in. That means this doesn't work and this does work. It means this does not work, it means this does. So there are 3 answers. It is negative infinity to negative 6 bracket, because 6 is closed, in union with parenthesis negative 3 because it's open, to 1 bracket because it's closed, in union with parenthesis 3 to infinity parenthesis. Get rid of this arrow here. And that's your answer. This one, graph. I'm going to factor the bottom. Because this is a negative 9, this needs to be negative 10 and 1. So there's your factors. Okay. So what, nothing cancels. So you have 2 vertical asymptotes. One of them is x equals 5, and one of them is x equals negative 1/2. There's your vertical asymptotes. Because the numerator's degree 1 is smaller than the x squared on the bottom, your horizontal asymptote is always y equals 0. Okay, so that's drawn in. Your x-intercepts are found by setting the numerator equal to 0. So x is 1 is your x-intercept. Now, it's hitting. Sometimes when you have 2 vertical asymptotes, the middle curve will look like a snake and it'll come down like that. But the other 2 will hold true to the asymptote. But this one obviously is going to hit that. And the y-intercept. Let the x's equal 0 in this problem. If you let all the x's equal 0, it looks like this. So it should be 1/5. 0, 1/5. So that's about right here. Wait, that's not right. I did negative 1/5. Sorry, it's right there. Not this one. X, it's up there. So we're going to then, since it's a graphing calculator quiz, for this portion of it, you would then go like this, x minus 1, and then 2x squared minus 9x minus 5. So I think that's good. Minus 5, this graph. That's holding true to my vertical asymptote, negative 1/2 and 5. Now, this looks really small, but it's not small. It actually goes all the way up, and this one goes all the way down. Don't be deceived by this graph. We're going to get some points. Let's go to our graphing calculator. I would like to see some points like 2, 3, and 4 first. Let's finish this curve. I'm going to look at 2, 3, and 4. So 2 is negative 1/15, so that's really small. 3 is negative 1/7. 4 is negative 1/3. So I think I can finish my middle curve now. So my middle curve, it's not pointy like that. Sorry, it's supposed to be curvy. And then I need some points like negative 1, negative 2, negative 3. So let me go back up. Negative 1 is negative 1/3. Negative 2 is even smaller. So they're going to get really close to the y-intercept here, it looks like. So really close to the y-intercept. Hit that. Follow your asymptote. I don't know why my curves are looking so boxy. And then I need some numbers like 6, 7, and 8. These are all numbers around your asymptotes. So 6, 7, 8. 6 is 5/13. 7 is 1/5. And there is your picture. Find the equation of the slant asymptote. Okay, y equals. Remember, we're looking for y equals mx plus b. So we need a synthetic division. 1, negative 7, 6. Put a 2 outside. Bring down the 1. 1 times 2. Add. Ignore the remainder. Write it in slope-intercept form. 1x minus 5. That's not a plus. X minus 5. Write equations of all asymptotes. So we have to factor this. This one's x plus 5 and x plus 1. This one, take an x out. And then factor it. So all your factors, if you put them all together, look like this. So this is your problem in factored form. Question number 1, is there a hole? The answer to that is yes. So we're going to remove this. So now we're left with x plus 1 over x times x plus 3. This is what's left. So over here, the hole, set x plus 5 equal to 0. The hole is negative 5 something. That negative 5, if you plug it into this leftover part, negative 5 plus 1, negative 5 times negative 5 plus 3 is negative 4/10, which is negative 2/5. What else? Okay, so this is what we have left. What's the vertical asymptote? X equals negative 3. You are right. That's the only thing that's left. Oh, wait, there's another one. There's 2 x's in the bottom. So there's also x equals 0. There's 2 x's in the bottom, so they're both vertical asymptotes. Now, the horizontal asymptote. I would look from the beginning. Look at the beginning equation. Look, see this right here? See how this is 1 smaller than this? It's y equals 0. It's never going to change. There is no slant asymptote. Now, x-intercepts and y-intercepts, the y-intercept I actually get from the original problem. y-intercept, if you let x equal 0, that would be 5. But if you let x equal 0 on the bottom, it would be 0. So it would be 5 over 0, which is actually undefined. So there is no y-intercept. The x-intercept, you're going to set the numerator equal to 0. That's the leftover right here. So that would be x equals negative 1. So that's everything. Graphing-wise, I'll just do a quick little graph. You have a vertical asymptote at 0. You have a vertical asymptote at negative 3. You have a hole at negative 5, negative 2/5. You have an x-intercept at negative 1, 0. And then the rest of this you could graph. But my guess is just by these points, it looks something like this. And that's how you do it. Find all the zeros of this problem. Calculator. You could either punch it in the calculator. Let's just punch it in. You can graph it and see where it crosses the x-axis. Looks like it's crossing at 3. I'll look at my t-table. Yes, it does look like 3 is a 0. So 3 is a 0. So one way you could do this is do synthetic division. And then take this quadratic that's left, set it equal to 0. X squared equals negative 36. X is plus or minus radical negative 36, which is plus or minus 6i. So your answers are 3, 6i, and negative 6i. And you'd be done. Or you could have factored this. You could have taken the first two terms plus the second two terms, like this. Take an x squared out. Take a 36 out. Bring the x minus 3 binomial GCF out front. Set this one equal to 0. You get x equals 3. Set this one equal to 0. X is plus or minus 6i. So you could have done it with factoring as well. And last problem. Factor the 2 out of the top. Factor a 3 out of the bottom. Factors on the top are x minus 4, x minus 1. Factors on the bottom are x minus 4, x plus 4. So you are removing a factor. That's where the hole is. So the hole is 4 something. So if you want to know what it is, the part that's left over, plug a 4 in. So this is 2 times 3 or 6. This is 3 times 8, which is 24. I feel like something should be negative here. Guess not. This is 1/4. 4 and 1/4. So therefore, this is what's left. That's what's left. So what's the vertical asymptote? Negative 4. So there it is. What's the y-intercept? I get the horizontal asymptote from the original. See how the original one looks like this? See how they're the same? Your horizontal asymptote is 2 divided by 3. The leading coefficients when they're the same. Y equals 2/3. So the x-intercept, I'm going to go to the new one. X-intercept, look at the remaining factor, x minus 1. So the x-intercept is 1, 0. Y-intercept, I get from the original. You can get it from the new one, but I think it's just easier in the original. So if you let x equal 0, here, 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 and here, or just these three, this is your y-intercept, 8 over that, so that's negative 1, 6. And I can graph that. I need graph. So we have a vertical asymptote at -4. You have a hole at 4 1/4. You have a horizontal asymptote of y equals -2/3. I really need a new graph for this. Let's do it on the back of this one. Let's start over. We have a vertical asymptote of -4. We have a horizontal asymptote of y equals 2/3. We have a hole at 4 1/4. We have an x-intercept of 1 0. We have a y-intercept of 0 -1 6. And you would just need a couple other points to finish this off. Figure out the other points. I'm not going to do exact ones, but that's what it looks like. The last question is, as x approaches -4 from the right, and as x approaches -4 from the left, what does the y do? So as x approaches 4 from the right, so put your follow the curve. As x approaches -4 from the right, what is this doing? That one's -infinity. As x approaches -4 from the left, it's shooting up. And that's your problem.